This is a very simple 3D printed binary to decimal converter. You can find the STL files for it on my Thingiverse page, and there are only two files, one for the base and one for these moving plates. You will need 10 copies of the plates because the converter has 10 bits. The only extra is a piece of filament that goes through all the holes in the printing to serve as a shaft for these plates to move. Just make sure to melt the ends of the filament so it doesn't fall off. The binary system uses only zeros and ones to build a number, and despite this apparent limitation, it's very useful in electronics because zeros and ones can be translated as simple electric states such as on and off, thus allowing circuits to perform math operations. On the top row, we see only zeros. The number 1 will appear when you switch one of the plates up and cover a zero, thus revealing a number underneath. On the bottom row here, you have powers of 2, since 2 is the basis of the binary system. So from right to left, we have 2 to 0, which is 1, 2 to 1, which is 2, 2 squared, which is 4, 2 cubed, which is 8, and so on, up to 2 to the 9th power, which is 512. For converting a number from binary to decimal, all you need to do is build the number on the top row here, always making sure to align your number to the right, just as in a calculator. And as in the decimal system, zeros to the left don't add anything to the number. So let's make an example with a 7-bit or 7-digit number 1010011. So for a 7-bit number, we don't need the first 3 plates, so we just put them down and build the number with the remaining plates 1010011. By doing so, we leave some powers of 2 on the bottom row uncovered, in this case 64, 16, 2 and 1. The decimal number will be the sum of these powers, so 64 plus 16 plus 2 plus 1, leading us to the result 83. So 1010011 in binary is 83 in the decimal system. For converting a number from decimal to binary, we need to factorate the number into powers of 2. And that's because for every decimal number, there is a single combination of powers of 2 that sum up to that number. So, for example, let's convert 37 to binary. So, for converting 37, we don't need any power that is higher than 37. We only need powers that are smaller than it. So for 37, the only combination of numbers of powers of 2 that can give us this number is 32 plus 4 plus 1. So we don't need 16, we don't need 8, and we don't need 2. 32 plus 4 is 36, plus 1 is 37. By doing that, we have on the top row the number translated to binary, which reads 100101, and that's 37 in binary. So I hope you guys enjoy this converter. You have a nice time printing it, and see you next time.